Okay, ladies and gentlemen, welcome to another week. Welcome to EECS 440. It's good to see you. Thank you for being here. You just had a submission. I saw a lot of you submitting, maybe a bit at the last moment. What was due today? You recall? Due just a moment ago was, bingo, P1 milestone, right? And you can see on the schedule, P1 milestone, you only had 7 days, okay? And you had a bunch of those kind of intro tasks. Now, hopefully, all of you at least have kind of that, line trace-based selection affordance system set up, right? Hopefully, you've got things like the light switches going, toggling off and on. Hopefully, you've got a bit of a blocked out laboratory. But if you don't have everything finished, remember, that's okay. It's not the end of the world. In fact, you don't have to have every task finished completely to get full credit. You just have to have a good first rough draft in, okay? It doesn't have to be complete. And you should still get points for those tasks until the end of P1 Gold, when we want you to go back in and really finish those tasks up and get them to a bug-free, high-quality state, okay? But we are on to P1 Alpha. And P1 Alpha, if you look, this is actually kind of a tough week. In fact, I think some students would say this might be the toughest assignment in the entire course, okay? Because you are doing things that you've kind of done before, but you're doing a whole lot more of it, right? So this week, you created a few interactions, a few actors, a few objects, right? But if you look at these red tasks, you're going to be doing more objects and the interactions on them are going to be a little bit more involved, okay? You're going to have things like a passerby who walks outside your windows and needs to have a bit of routing set up, okay? Nothing crazy, but you do need to have them, for instance, walk around a corner, okay? And get them into a loop so they do this infinitely. You're going to have tasks like the whiteboard task, okay, which is going to put some pressure on your understanding of the selection system, okay? How is that selection system set up? How did we make those affordances work, okay? Because the thing about the whiteboard task is that you're not just going to be aiming at it and then poking once with your trigger, right? That whiteboard, you're also going to have to draw every frame on it, which means you have to send in additional information. You have to send in the location that you're hitting the object, right? You also have to start doing actions when the trigger is held and not when you're right, just clicking it. So you'll have to make a few adjustments to the selection system so that it can support a new type of interaction. a continuous interact to go along with your normal interact, okay? Anyway, you've got a lot of help for a lot of these tasks. This task doesn't have any help because it's just the whiteboard. Like, download a whiteboard, put it in. But you'll see that there's another task for the whiteboard interaction, which has quite a bit of help, okay? Hopefully this will keep you going. You'll be doing day-night progression. Remember, a lot of these, you just have to get a good rough draft in, and you can finish up in next week, okay? But anyway, I wish you luck. I'll be here at office hours from 6 to 8 p.m. If you want to get rocking on those, and I do recommend it. Hopefully you're starting to feel just a tiny bit better with Unreal Engine. There's so much to learn. There's so much in Unreal. There's so much you can do with blueprints. And you're always going to feel that friction. When you step into any sort of new technical ecosystem, it's going to be a couple weeks of kind of grinding your teeth, okay? Running into annoying little bugs. But you're really going to start to move a lot faster, and all of this is going to get a lot more fun, I guarantee. Okay? Just give it another week or two, and you'll get there. Okay, so let's go ahead and take a look at some stuff. So I've got a company for you. This one is near and dear to my heart. It is Spellbound AR. This is a company I believe I showed you during the first day, but only a tiny glimpse of the company. This is a company that its entire engineering team is made of EECS 494, 440, and Wolverine Soft students. So a great group. They did a great job. I'm going to show you their website, and then I think I'll let you watch their entire trailer. They have brought in about $1 million. They are based downtown Ann Arbor, and they're not super hard to find if you want to go interact with them, ask them questions. Currently, their big product is a scavenger hunt that has been deployed in several different hospitals. I think some Cleveland hospitals, I think U of M Health, and then Stanford Health on the West Coast as well. And basically, it's a scavenger hunt that brings characters to life, allows you to play mini games with them, train them, Pokemon-style stuff, right? But the point is to kind of get students out and walking around and rehabilitating themselves, okay? So, patients don't have to hate the wait. So how do you keep little kids, preoccupied while they're waiting? How do you keep them distracted? How do you prevent them from focusing on painful stuff? Once they get home, how do you get them doing the exercises that doctors need them to do, right? So you can take the application home with you, take the device home, the software home, and stuff like that. So pretty cool stuff. Let's go ahead and let's show that whole video, okay?
Spellbound is a mobile app that uses augmented reality technology to bring paper books to 3D life. It can recognize what it's looking at and pull characters out in 3D. It can read the story aloud, and you can interact with the paper page in ways you've never imagined before. We work with hospitals who are actively seeking to improve the pediatric patient experience and who want to arm their child life specialists with tools to distract, engage, and entertain. It's making the hospital more interesting, perhaps music to create scavenger hunts or something to get kids up and walking and exploring the hospital and being compliant with treatment, but also creating those experiences that are going to be normalizing for them.
It's a really good tool to help distract them and keep their mind off of whatever anxiety they might have. We also use it for long procedures or for long stays when patients can't leave their room. The greatest thing that I've seen about augmented reality is watching patients and their parents react at the same time and reacting together and both kind of celebrating that.
They get to have a moment of joy in a place that could just be overwhelming. Spellbound started with books, but it's really about creating whole worlds of imagination for children.
So a quick bit of trivia. In the early days of Spellbound, they kind of had the wrong business model. The entire product was just very, very focused on these pop-up books, right? the way that the company made money was they would give away the app, the software, for free. But if you wanted to purchase a pop-up book, well, you'd have to purchase that. They would order it, and they would take a margin on that. People didn't care enough about the pop-up books, and getting revenue that way just wasn't really working. So the team kind of moved to kind of a more custom consulting firm kind of style, which basically means, hey, Stanford, you want something special? You want a mural? Yes, we'll come build that for you. We'll travel out there and do it. And that was a little bit more successful for them. Now they have a scavenger hunt game, which they can actually deploy easily to many hospitals. And I think that's going okay-ish for them. They haven't been growing very much, but I don't think they've been shrinking or dying either. So anyway, a pretty cool company. And these days, I think they mostly make money just by doing larger deals that fit each medical institution kind of as they meet them. Anyway, very cool company. I hope, I wish them all the success in the world. Okay. IGD Ann Arbor, this is an opportunity for extra credit. This Thursday, we'll be having a talk called The Secret Life of Games. This is a talk, an introduction to hacking and modding and cheat codes. We are going to be ethically hacking 2 different games live at this talk. This event happens once a month, and usually we have an industry guest. This month you've got me, and so I'll be giving the talk myself. Should be a good time, and if you've ever wondered, how does someone go and create mods of their favorite games? How does a game get hacked to, for instance, boost your score or reset your health or change the game's logic, introduce new features, new modes? You'll get a feel for how that can be done at this talk. You take a selfie, you upload it to Canvas. You'll also get, I think, 2 points of extra credit as well for immersing yourself in the local community. A quick, very nice announcement over just the lunch break an hour ago. EECS 298, the course I'm spending a lot of time designing, is approved now for FlexTech credit. So if you need FlexTech credit to graduate, then this course will get you 4 FlexTech, and you'll come out of it learning Blender and getting much better at creating your own characters, your own objects, environments, not only in a 3D modeling program with that T-pose, but animating them and then bringing them into an engine, making them playable and interactive and full of charm and life. Okay? So, if you need a course, if you need FlexTech credit, keep that in mind. A quick funny thing, a quick anecdote. This is the first course I've ever made that is open to anyone, like literally anyone, on campus. There are no prereqs. And as a result, I have to go to each department on campus, like computer science, and say, hey, will you please approve this course for FlexTech? Okay, I got them. I have to go to Stamps. Okay, Stamps, School of Art and Design, will you recognize this course for elective credit? Okay, great. I have to go to the LSA because they have some of their own special types of credit. Okay, I think there's a creative expression credit that I'm going to try and get for this course so that LS&A students can accomplish their objectives with it. I think I have to imagine Taubman, the architecture. What kind of special credits do architecture students need? This is just kind of an inside look at course design, but designing the course is only half the battle. You design the course, you make it as great as you can, but then you have to kind of get it to work within the structure of the university. Sometimes it's not too hard. Sometimes it's a bit harder, but that's what I'm going through right now. Okay, so ask me questions about that if it's interesting to you at all. And yeah, hopefully we'll have a lot of students with a lot of good 3D modeling and animation knowledge and engine knowledge and importation knowledge very soon. Okay, I'm super excited about it. The end result here is that all of our projects and games and all of your portfolios start to look really good, like way better than they used to look, okay? All right. You remember that phrase? How many of you have heard the phrase, don't judge a book by its cover, okay? Now, the very existence of this phrase suggests something. What does it suggest to you? That way too many people, in fact, pretty much everyone judges a book by its cover. And that's something we've always struggled with around here. Our games, our projects, our XR apps tend to be well made and well designed under the hood, but they tend to not look all that great aesthetically, right? I mean, we're engineers. That's not usually our focus, but we got to get better at that, okay? There's no getting away from this fact that aesthetics really, really matter, okay? Image is not everything, but it's something. It's definitely something. Okay, so how are you starting to feel your thoughts really quickly? I'm really curious. How are you starting to feel with Unreal? Like, is there still some friction? Where's the friction coming from? Are there things that kind of confuse you? Where's most of your time being burned? Have any of you accidentally burned some time? Yeah.
I feel like I always kind of confuse like affordance component, like
Yeah.
what object you have this affordance
Yeah.
and whatnot. And
Yeah.
like different component like get and set, like different variables.
Yeah.
Getting them to work so the game works.
Yeah.
Hard.
Yeah, definitely. I'll tell you, the big thing with affordances, an affordance is a blueprint component, but it has one special thing, right? It has that interact function. That's the only difference, okay? So you think if I need the interact function, I need to click on something, I should use an affordance. Otherwise, I can use any kind of component I want, really. Yeah, it's tough, right? Especially if you haven't seen it before, but you'll get there. Okay, yeah? Lighting. Oh, yeah. Right, lighting has been the bane of game dev for a very long time. It is very computationally difficult to deal with, lighting and shadows. And so a lot of hacks and shortcuts have been introduced into our engines. For instance, light baking. So if you go up to the build button and create a build, it will bake all of the lights. All of the lights that are stationary will be baked into nearby objects. That takes a while, though. And if you ever move an object, then suddenly the shadows and the lighting doesn't make sense anymore. It looks weird. It's funky, okay? So yeah, lighting can get messed up in 1,000 different ways, as you are all discovering, okay? Anyone else? Yes?
When importing models in, sometimes it's not the right size or
Yeah.
the pieces are like scanned.
Yes, sometimes, depending on how the 3D artist created the model, you'll bring the model in and it will kind of be busted or broken, right? Or the materials won't work, or the object will be inside out. Have you ever seen that? The normals will have been accidentally reversed. Sometimes you'll look at it from the wrong angle and it will vanish into thin air, right? So that's actually some of the stuff that we'll be learning in the EECS 298 course, right? How do you prepare a model correctly so that it can easily be brought into an engine? Because a lot of people on Sketchfab don't quite know what they're doing as far as making a model engine ready. And so that's definitely going to happen. The thing to take away here is that 3D software in general, whether you're talking about Blender, right, a 3D modeling and animation tool, or an engine like Unity or Unreal, these are difficult programs. They're very powerful. You are trying to deal with a 3D space, but you only have a 2D interface, your flat screen, your mouse cursor that can only move in 2D. And so that just creates tremendous complexity and difficulty. I'm going to show you a fun video by a fellow 3D art student, 3D engine student, Savannah XYZ. Her videos are very funny, and maybe you'll get some of the jokes. We'll see.
Welcome to 3D software. Please enjoy your stay. There's so many things to do, so please let's not delay. We've got limitless features, most good software, and lots of little quirky bugs that we've engineered. Welcome to 3D software. Load up and take a chance. You can make some tricks or born or watch or do the Fortnite dance. Topology's abysmal. It's not optimized. But throw it up on Twitter and we'll call it stylize. Welcome to 3D software. You'll never feel alone. Get that shit from Warhammer. Make the units flow. Unity, Unreal. Which one do I choose? Click on the tutorial that has the most views. Welcome to 3D software. Sure to save your file. Recreate your you know that's slow. But shut up and watch the 12-part series on making bread dough. This is super boring, it's down to 1.5. Oh fuck, I missed this step, I gotta rewind. Make any games and sweater for a frog. Make a short sorry, match cheap for photos can't talk. Monkey is a skull and a 3D press small somewhere. But if you shadow or stilettos, watch my demos to Nintendo. Make a daily shader, make a light, make a costume. And creating a web 3, creating the presume. Find out the laptop, be they just the worst. But before you do, download the substance update first. Could I guess you and rendering all of the time? A little bit of rendering all of the time. Subscriptions are a tragedy and currencies a crime. Compiling and rendering all of the time. Could I guess you and rendering all of the time? A little bit of rendering all of the time. Subscriptions are a tragedy and currencies a crime. Compiling and rendering all of the time.
Yeah, so making fun of these tools, despite their power, is a time-honored tradition among art students, but also among game engine students. You can tell Savannah XYZ is a channel that's more focused on 3D modeling and animation. More of a video I'll show in EECS 298. But learning it all, if you're going to learn Unreal, if you're going to learn Unity, moving into the 3D art side of things is a good idea. Okay, really quickly, I saw this headline, Wall Street Journal, a pretty good source. Companies finally find a use for virtual reality, and they're doing so at work, okay? Like we said during our first couple days, a lot of the big gambits for XR have kind of flopped, okay? Metaverse failed, but we're seeing a lot of more niche success in a lot of tinier areas. So first responder training, employee training, warehouse training to keep people safe, medical training, okay, and medical rehabilitation. And so one of the big questions is how much of an industry can these more niche use cases support? Hopefully a pretty significant one. But we'll talk a little bit more about that in the future. In any case, yeah, pretty cool headline. You can check it out on your own if you want to. A quick reminder for the Viz Studio, this is how we want you to clean up and package your headsets when you're done. Get them kind of positioned on the desk, and then get this cable kind of wrapped around if you can, okay? If you can't, if it's too short, that's fine. But what you don't want to do is you don't want to have the cable hanging off like this, or worse, you don't want it on the ground like this. What happens is that these extremely expensive headsets, people will roll over these cables when they're on the ground, right? The cable will hit the ground. You'll roll around in these chairs, and rolling back and forth on the cable destroys the cable, destroys the headset, okay? And so we want to keep these things going as long as possible. So please try and clean your space up after you're done if you can, okay? All right, you already saw P1 Alpha. It was released. And if we want to be able to get P1 Alpha done and get plenty of good sleep, we need to start talking today a bit more in depth about what is going on within Unreal. What are you doing when you try and program in Unreal? And how can you utilize some of the features that blueprints give you to have an easier time, okay? So we're going to do that today. It might be a short lecture. Maybe we'll go into materials, which is a very interesting topic. But we'll see. We'll see how it goes. So you've done some blueprint scripting, some visual scripting. So do you feel anything when you see this? Do you feel anything when you see this tangle of wires and nodes and things, right? Whether you're building your own computer or whether you are walking underneath some crazy public infrastructure, I think this is like some electrical wires someplace in India or something. This is what you don't want, okay? When you're programming in Blueprint, things can get very spaghetti very quickly, and you really do not want something like this to break out, okay? It is very tempting to try and build these massive event graphs in your blueprints that are just spaghetti-licious, but this is the lecture where I remind you that Unreal Blueprints, they have functions, okay? They've got functions, they've got methods, they've got events, things you can use to help you organize, but also to help you debug, okay? So this is more what you want, okay? You don't want to go too much bigger than something like this. Node-based programming, visual programming is very, very common. You've seen this before. This is actually a node-based tool that allows you to create dialogue for your game. This is what I used in my last project. Unreal is a bit of a quirky engine, but it is so incredibly successful that it is quickly dominating the entire industry. It is one of the tools that powers games like BioShock Infinite up top, okay, gorgeous game, but also games like Fortnite, okay, a little bit more casual. Unreal has also been used for virtual reality experiences as well. So Creed, Rise to Glory, boxing, a VR game, and games like Vader Immortal with Star Wars, okay? It can also do much smaller kind of indie-style games as well, all right? It can do basically anything you need it to do. Now, a quick note. This is Blueprint visual scripting. You've seen it before. One thing you haven't seen much of is Unreal C++, okay? You probably have heard that there are two primary ways to program Unreal projects, Blueprints and Unreal C++. There is a third, it's called Verse, which is kind of a strange, like managed language, kind of a C# alternative that is being introduced right now. But you'll generally choose one of these two for a lot of your stuff. One of the advantages of Blueprint visual scripting is that it's faster iteration. You can compile much more quickly. It doesn't need a super long compilation period. In Unreal, right, Unreal C++ is quite slow. In fact, often when you make a change to Unreal C++ code, you have to actually quit the editor and relaunch the Unreal engine, okay? Very slow. It can take, sometimes minutes at a time between code changes. It's very annoying to do this as well. Blueprint scripting has recovery from exceptions. If you have an error that shows up, something is null, right? You'll just get a little warning message in your output, and you're fine. The project continues running, and you're all good. If you have an error or exception that goes unhandled in your Unreal C++, you're going to crash. Okay, the whole thing will crash right then and there, and you will be in a world of hurt. Okay. In Blueprints, you basically get to learn quite a bit faster than you do in Unreal C++, which has a lot of dark corners. Do you remember from 281 and 280 your STD vector container, right? Super nice container, okay? It expands, kind of a dynamic resizing array. You can't really use it in Unreal, okay? They have their own unique container that does that. You can't use the standard vector. How many of you remember the STD string data type, right, from 281 and 280? Right? It's a nice, string data type. You're used to it. You're probably used to some of its functions and quirks. In Unreal, they have their own data type, their own string container. And so you can't use that either. In fact, some people say that Unreal C++ is so different from normal C++ that they don't even call it C++. They call it Unreal++. Anyway, right? This is a good thing to eventually learn, but we've got to learn Unity as well. We've got to do some AR stuff in this course. And so this semester, we'll be focusing on Blueprint visual scripting, and you can make the switch over to Unreal C++, probably gingerly, but you can do that on your own time if you like, okay? If you're sad about C++, there are some great videos and tutorials on Unreal C++ that can get you rolling, okay? You can watch that on your own later if you want to. If you are making a final project using Unreal, VR project, then you might need to use Unreal C++ if you want to integrate with a third-party library, okay? So you might want to come back here if that's needed. So why visual scripting? What's the point, okay? Why bother? Well, if you go online, you'll find a lot of comments asking about, should I go with Unreal Engine or should I go with Unity? From people who are trying to learn a first game engine. You'll find comments like this from G.J. Harding. I have no real code knowledge, but come from an art background, so it's Unreal for me because of Blueprints. I think it's the more friendly of the two versus Unity. And it's an extremely common opinion, okay? So a lot of people who don't have a programming background, they look at this code, right? And they don't understand what the tokens mean. They don't understand what these brackets are even for. What does void mean, okay? They're looking into the matrix here, and they're having kind of a difficult time. By the way, what is coming up on Wednesday? Anyone know if you look at our schedule right here? Our first film session, okay? So this is your final chance to watch the film, The Matrix, and to basically get credit for it. If you can't join us, you still have time to watch it yourself and submit a report on Canvas. But I think we'll be in 1017 DAO. This timing and location might update, like tomorrow or Wednesday. I'll announce it if it does. But yeah, we will see you together at 8 p.m. for the film. You will not have to write anything, and we won't have any lecture that day, okay? All right, anyway, back to it. When you see all this, when someone who can't really program, they just don't have the experience or knowledge, sees this, they see crazy stuff, okay? They see the matrix. They can't make heads or tails of it, and it's very intimidating, all right? And if this is pretty easy to you now, remember, it took you a few years probably to get really comfy with C++, and they don't have that time, okay? When you look over here, though, an artist will not see code. In fact, an artist usually won't call this code. You know what they see? They see Lego blocks, okay? Which they are very used to, which are friendly and fun to mess around with, right? And so you can see that one of these is just much, much more approachable, despite the fact that actually they're pretty much the same thing. In fact, you can even order them to make them look very similar, okay? So anyway, in textual languages, the relationships are they require a lot more knowledge to see, okay? Over here, the relationships are much more obvious. You just follow the lines. Over here, you have to make a connection between velocity being used and velocity being declared, okay? And it's just not as easy, all right? There are a lot of syntax issues that you can run into, okay? How many of you have gotten blown up by the missing semicolon error in the past, right? Dang, my code won't compile. Why won't it compile? Oh my gosh, I forgot a semicolon. You fix it, and now it's working, right? Those kind of errors are terrifying for people who don't have a whole lot of time to learn programming, okay? They just want to do stuff. Over here, it is actually not possible to mistype or misremember your syntax, okay? If you, for instance, accidentally change this C to an X, you just won't find a node called add Axter world offset, okay? You will probably, in the little search function, you're probably going to find a node that you actually want, add actor world offset, okay? Over here, programming is terrifying, I can't do it. And over here, people say it's not programming, it's blueprints, okay? Even though I'm going to make the case for you that this is genuinely programming. A quick anecdote, my colleague who teaches at, actually Corbin Reeves now teaches here at U of M in the UARTS department. So Azure Ravens Entertainment, this is Corbin Reeves, my colleague who now teaches here at U of M. He's also taught at EMU, LTU, Kettering, and other places. He's got a really cool studio. He makes a lot of great games. And he told me, we'll use Unreal Engine over Unity every time. Our team is art heavy. We don't have many programmers, and so blueprints are really a godsend. Okay, super important for us. Okay, they've got one main programmer who can write C++ and C# and do everything needed. All the other artists, they have to use blueprints, and they can use them. Okay, so I want to make the case for you today that blueprint scripting is standard programming. It is. Okay. And you'll start to get a feel for this as you get deeper into Project 1 and then on Project 3 when you'll do crazy stuff, okay? So variables, right? Let's show you a variable I've got called the character data component, okay? Variables are configurable within the Blueprint editor. When you go in and you look on the left side of your Blueprint window, you're going to see a little tab to show you what all your variables are, including their type, including whether they're visible. And they have all of the features that you would expect. There are built-in data types, just like you're used to in C or C++. Floats, integers, booleans, strings, okay? An actor, which is kind of the default object data type for things like a cube, or things like a wall, or a door, or a light switch, okay? Or a light. They also have custom and user-defined data types as well. Okay, do any of you know what the Big Biscuit data type is? Okay, this is a data type that we would have created. And once we create that data type, you can have a variable of that type. Okay, you think back to 280 or 281, you create a custom class, and now you can have variables of that type. It's very, very nice. There are also different container types. So you might say, my favorite foods variable is going to be of type string. It's going to, it's the food name. But I don't want a single string. I want an array of strings because it's my favorite foods, not my favorite food, right? And so you can also see we've got a set down here, an allies set. So if you have any actors in the scene, like some NPC characters who are your friends who are going to help you, complete a mission. What is a set versus an array? Anyone know? What's the difference? What is the common difference between a set and an array? Yeah.
Set is unordered.
Yes. I don't know if this one is, though. Sets are, well, it depends. In C++, there is the set container. That actually is ordered. The unsorted set, or unordered set, is the unordered one. That's much faster.
I guess there's only one of every element.
Bingo. Uniqueness is the more common attribute of a set. So in a set, you are saying, hey, I don't want any duplicates, okay? Any object that's going to be in this set, there's only going to be one of those, all right? This is really good if you're trying to collect a list of actors and you're worried you might accidentally put the same actor in twice, okay? Got to be careful about that. Okay, right? So if you want to go and turn one of these variables into a container, you click on the variable, and over on the right, you'll actually see this little icon, and you can change it from single to array to set to even map if you want to, okay? You can do the expected object-oriented stuff with these things as well. So you can say, hey, I want my favorite foods variable to be a private variable so that they can't be accessed by objects outside of this one, all right? You can have default values, okay? So that's also very common. In this case, we say our favorite foods variable is an array of type string, and by default, it starts with notai and Totoro in it, okay? How many of you actually love notai? Anyone? Yeah? Okay. That's like an addiction when I was an undergrad. If I had a bad exam, cheer me up, just go straight to notai. Several times a week, and not super healthy. Definitely not good for the wallet, but it's good stuff. These variables can also be made inspector editable. They can be made visible, okay, by clicking this little closed eye. The eye opens up, and then once you do so, you can actually edit that value, okay? So this is the inspector. If you take this chair right here, or the editor, if you take this chair and click on it, okay, we're going to get to see all of the nice details, all the components that that chair has. Now, the chair has the static mesh component by default. That is the component that's gigantic. It renders it, it gives it physics and collisions, all that stuff. But you can see it has a second component on it called character data, okay? And if you go ahead and you click on that character data, like that, click, now you can see that our favorite foods variable is right in here. And we can actually change our favorite food. And we can change it for every unique object, every unique actor that has that component. So maybe the chair has a favorite food of ginger deli, Totoro, notai. But the table, we give the table the character data component, and we change it to like Pizza House and Jet's Pizza and whatever, okay? NYPD. Good stuff, right? So not just variables, but we also have functions in Unreal as well. And right next to the variables, in fact, right above it, you can actually see the functions tab up there. Okay, right above the variables, we can click on that. And basically, this is your way of building a new type of node that you can reuse anywhere you want. So this is an example that's actually going to help you a lot on P1 Alpha. But during P1 Alpha, you're going to need to write logic that can reach out and find certain actors, okay? And here's a function that's going to do that. This is a function we've created. We clicked on this plus button right here. I typed it in, find all no-tie lovers, okay? With these functions, you can go in and customize their inputs and their outputs. So if I click on find all no-tie lovers, okay, I can go into this details pane, and I've got inputs and I've got outputs, all right? I can just click right down there. I can, for instance, add a proximity to search parameter. I think this is a float. So how far away can you be from a certain location of vector 3 data to find the no-tie lovers, okay? And if you have a specific dish, we can send that in as a string. So we've created a function that has 3 parameters coming in, okay? And you can see as we add these, little nodes appear. So we can actually use the information coming in any way we want. We can also add an output. So on our return node, because we're designing our function right here, on our return node, we have this output no-tie loving actors. This is a set of actor type. And we need to build ourselves a set and then plug it in there, and then it will come out of this function, okay? And that's how we design ourselves a new function, a new node. So this might be kind of hard to see, but I encourage you to kind of come a bit closer or look on the Twitch stream or something. But I'm going to ask, what do you think this function, well, you already kind of know what it does. I want one of you to explain to me how this function works. How does it work? Remember, you can also just get a close-up of the screen on your laptop if you go to twitch.tv /ayarger. So twitch.tv /ayarger, okay? You should find it, click the little bread dog right there, and you will get to see exactly what I'm seeing on my screen. Anyway, would someone care to tell me, kind of walk me through how this function is working? How does it find all of the actors who are no-tie lovers in our current map? And I have to remind myself. Okay. What do you think? How are you feeling? This is actually kind of a tricky one, okay? It's a big bunch of logic that we're packaging up into a function so that we can use it later easily. How does it work, though?
It looks like you go through and get all of the actors of, I'm not sure what class I can't read it.
This is type actor.
Okay, so
So-
you just get all actors.
Yeah, this is one of the most powerful nodes that you can know about, okay? You're going to want to write this one down for your P1. This is a node called get all actors of class. Now you can choose, do I want to get all the tables? Do I want to get all the light switches? Or do I want to get all actors, okay? If you specify actors, it'll just grab you all of them that currently exist, okay? So yeah.
So then it goes into a loop, and it's going to look at
Yep.
every actor.
Yep.
And then set a variable current actor to use later.
That's right.
Then
Yep.
for every actor, go through all of their components.
Okay, all of their what kind of component?
The components of, what does it say?
It says character data.
Okay, character data meaning the component we created.
Yep.
So if it has,
Uh-huh.
yeah, it's going to return if it has any, all of the character data components.
Okay.
And then loop through, if it has a character data, then it has a favorite foods.
Yep.
As we defined it.
Yep.
Loop through that favorite foods and find if it equals no tie.
Yes.
Then if that's true, we add it to a variable we've declared called result. And
Yep.
make that set and use that current actor to, take that variable and add it to the set.
Yep.
That's what we return at the bottom.
Yep, exactly. That's right. Well done. So with my mouse, you can follow us over here. First, we grab every single actor in the entire scene, the entire map. We iterate through all of them, and we want to grab the get component. Well, we want to grab the character data component from that class. If you remember what that was real quick, right? The character data is a component that has a favorite foods array. So if we want to find the no-tie lovers, we got to grab that component on the actor, and we got to look into it and see if we can find stuff. So we're going to grab that character data component, which has a favorite foods array. We're going to iterate, do a for each loop through all of those foods. And we're going to check and do a comparison. Is this food equal to no tie? Is this food equal to no tie? If true, we add this current actor to a result set. And at the very end, after looking at every actor and all the foods they like, we return that result set. That'll give us all the actors who like no tie. Okay? So that's quite a lot. It's quite a mess, all right? Now, this helps us keep things very clean. So every frame, we can do some logic, okay? In event tick, every frame, we can find all the no tie lovers. We get a set out of that. We can then take the length, append it to a string that says no tie lovers that exist, and we can output that. So this logic, every single frame is going to be telling us how many no tie lovers currently exist, okay? And this is much easier to read than the stuff up here, okay? And so that is some of the power you can get out of functions. And you will need to use some of these powerful nodes on P1. You really want to remember get actors of class and get component by class. Super useful, okay? All right, the hints should remind you of that. So comments. Comments are kind of interesting. They have a weird shape in Unreal. They look like this. They're these little boxes. They are not nodes themselves, but they're boxes that you can give titles to, and then you can actually stick your nodes inside of these boxes and move them around as a group. So if you have a chunk of logic, a handful of nodes that do a special thing, you can create one of these comments, put them into that box, and kind of organize and move them around and label them together, okay? Pretty cool. Classes are a thing as well, all right? In fact, blueprints are classes, okay? I think I told you this the other day. I hinted at it. But if you see any code that looks like this at all, then you are inside of a blueprint. This is a guarantee. You are inside of a class of some sort, okay? And this makes sense because where else do you put variables and functions? You only ever see those inside of a class for the most part, unless you're doing something with like Python or a language like that, okay? Every time you create a new blueprint or blueprint component, you are actually creating a new class, okay? With all that entails. So do you remember the Big Biscuit data type? Well, that is a blueprint, okay? It probably has some logic like that or some variables inside of it, all right? When you create new classes, when you create new blueprints, when you create new data types, you're going to see them inside of your content drawer, okay? You should see them right in there, and we can see Big Biscuit right here, okay? If we double-click it, we can look inside of it and see what's inside of that Big Biscuit. Whenever you create a new data type, you can then reference those in your code, and you can reference them as variable types too. So, right, biscuit preference of type Big Biscuit, okay? You can then instantiate instances of that class. So for instance, I'm going to click on this table and turn it into a class. I click on this button, okay? That's going to allow me to create a blueprint out of it. The name is table blueprint right there. Are we going to change it? No, we'll just keep it. So we just created a blueprint just like that, okay? And now we can go and we can instantiate that new class, all right? We can instantiate that new class out into our map by just clicking and dragging it in, like right there, okay? So, right, blueprints are very, very, very similar to classes, right? You create and design a blueprint, and then you instantiate many copies of that blueprint. In the same way that in EECS 280, you create a class, and then you instantiate many copies of that class to do the job, okay? A couple really, really nice functions here that might help you. Get all actors of class, right? You just saw that one. And then get components by class. Allows you to get the components on those actors of a certain class type, okay? Here's the find all noti lovers function, and you might want to refer back to this because it's super useful. You're probably going to be writing logic similar to this on P1, but it uses both. So when it comes to C++ classes, you've probably created some that look like this. It may have been a while, and I'll say in particular, C++ has kind of a weird syntax for its classes. You've got this kind of public colon, which creates a section. Everything in here is going to be public. Okay, anything outside of that area or above it is going to be private. And so you've got a bunch of variables here, right? Well, we can recreate all of these things, actually, in blueprints, okay? And I'll prove it to you. These are the analogs, right? Happiness is defined as a float down here. The UI is a bit different, but it's actually the same. And happiness is defined as a float up here, okay? You've got your three functions down here, human functions, eat, sleep, and talk. And you can see that these functions have also been created for our blueprint, our class over on the right, okay? And so it really is equivalent. You can see this process of us creating these things. We go, we right-click, we say, I want a new blueprint class. We go, I want an actor, okay? What do we name it? Human, okay? We just created a class of human. Now, when we double-click it to open up, at first, we're looking at the visual representation of human. Okay, we don't have any visual representation yet, but that's okay. We can add that later. We go to the event graph and we can see the logic, okay? But we can start creating variables and we can start creating functions however we want to. So for interests, we can go to the interest data type, all right, which is also a custom data type. We change it to an array, and now we have an array of interests. We have multiple interests. We can create a new variable called happiness and change its data type to a float and to a single float. I don't think I did, though. Yeah, I forgot to do that. I should have changed it to a single. We've created eat, sleep, and talk functions, and now you could fill those out however you wanted to and use them elsewhere if you want, okay? And there we go. We've got these events, yeah, it is basically the equivalent of programming the C++ right here, okay? The main takeaway, the main tangent here is that blueprints are classes, okay? And if you're used to using classes in other languages, this will make your programming experience much, much nicer, all right? So there is such a thing as a data-only blueprint, okay? And these are blueprints that are only meant as a store of variables, as a store of data, okay? If you ever see a blueprint, you open one up and it looks like this, you think, wow, that doesn't look like a blueprint. Where's the editing area, okay? Where are the nodes? Where are the links, the lines? Well, this doesn't have any logic in it. It doesn't have any functions in it. All it has are variables that you can edit and configure if you want to. So you will see some of these. A good example is the game mode that actually is responsible for launching the VR pawn, okay? That actually makes you begin the game, all right? Without this VR game mode, you actually won't launch into your VR pawn and nothing will happen, okay? Where you have classes, you're also going to have methods of reuse, okay? Code reuse, data reuse, all that good stuff. So you're going to have things like inheritance, okay? And we used this the other day to set up our affordance selection architecture. If you open up any sort of blueprint, you are opening a class, and if you look in the top right corner, you'll see that it has a parent class, okay? In this case, we have some sort of blueprint that is derived from actor component, okay? i.e., it's a component that you can pop onto actors. In Unreal, whenever you create a new class, you're basically always deriving from something. And the thing that you derive from is actually a pretty big deal. If you derive from actor instead of actor component, you cannot pop the component onto another actor. You have an actor, so you have to drag it out into the scene instead. It's not a component, it's a normal actor, okay? Like in other languages, public variables and functions will exist in that derived class, so you get certain things for free. An example, when you create a new class that's called AF Audio or AF Play Sound, right? When you derive from a parent class of type affordance, what do you get in your P1 projects? You get something for free, something that's very nice.
Interact function.
Bingo, you get that interact function, which you know is automatically going to run whenever the user clicks on that actor that has the component, okay? So it can be extremely useful. Functions may be overridden in the child class. You've been doing that quite often, okay? So example, we just went in and we overrode eat, okay? I click override, we go to eat opens up, and we can now customize it, okay? So in C++, this kind of thing looks like this, right? You've got a parent class of type human, and you have two children classes, a professor and a student, okay? The professor class decides to introduce a new function that no one else has called teach. They are a professor, so that makes sense. The student actually changes the eat and the sleep function that it gets from the human class, and it nulls them out, okay? Because students often do not sleep and they don't eat, okay? So that makes sense. Here's how you can do it, okay? So we're going to make a new class, and we're going to derive from human. Human already exists, and it has those variables, and it has those functions. I'm going to create a new class. I'm going to derive from human, and boom, I have a new class. It's called student. I double-click, okay? I double-click, and I already have the talk, sleep, and eat functions right there, okay? And so I can program my student's eat function to set the happiness to 1 billion, okay? Because when students eat, they tend to forget about life for a bit and their assignments, and they're much happier, okay? That's the theory. Anyway, you can do that kind of thing to move very, very quickly. Now, polymorphism is a topic we talked about when we built our affordance selection architecture. Hopefully you're getting a feel for why it's valuable, okay? It allows you to deal with any affordance component you want by just dealing with the parent of all those child affordances, okay? Here's another good example. This is a classic example. Imagine that you have a shape, but you say, well, I want to have many different shapes. I want to have circles and rectangles and other gons, right? Squares. And so I feel like square should be like a subclass of rectangle, but whatever, okay? And so all of these different shape-related classes will derive from the shape parent class. As a consequence of this, you know for a fact that every single one of these child classes will have a draw function. So we can call all of those unique draw functions just by kind of treating them all like shapes, okay? Use a base class type, in this case shape, to reference a bunch of unique derived classes in a standardized and efficient and elegant way, That's what's happening in your code base on P1. Okay, that's how that interact function works. Okay, very, very powerful and elegant. Polymorphism is the main reason to use inheritance, in my opinion. There are other ways to share code, but getting polymorphism is not so easy without inheritance. Okay. Anyway, yep, we use it for our affordance architecture, and you got to saw that a few days ago. So I want to quick talk about debugging, then we'll take a break. We'll come back with some materials. Okay. In Unreal, it's not textual programming. Okay, debugging is a little bit strange. Okay, you do have the classic technique of debugging by printing. Okay, that's one that we actually used together to verify our logic when we built the architecture together. Okay, it's this thing, right? You've seen this before, right? Standard cout. Is it working? STD endl. Right? A true classic, okay, you can litter these things throughout your code base and you can learn a bit, okay? Now, it's not a great idea. It is annoying. It takes some time. It can actually introduce bugs, but, you know, you do what you can, okay? We have in Unreal Engine a print string node that is the equivalent of cout, okay? Or in Unity, print or debug.log. All right. You can pair these with a make literal string node, which will create a string for you. And you can use append node to append and make different messages if you want to. It's a little bit annoying because it takes up a lot more space than it used to, right? Visual programming is super verbose. Okay. But you can do debug operations like this. Okay. When the game begins, let's say you want to understand the value of health. So you can make a literal string, health, okay, append it to the actual health float, and then you can print that out to the console, and you will see something like this. Health 0.0 in the corner of your screen, okay? You can also see this in your log output. If, for instance, you're not paying attention with the headset on, after you're done, you can look at this log panel, the output log, do a quick search for health, and you'll see that message coming out. Okay? All right. You can also do a couple clicks to actually watch execution flow through your blueprint. Okay? Watch this. We're going to run the game right now. We click the green button. Okay? Now, we need to tell Unreal which object we care about, which actor. So we're going to open up this menu and click, I want the say hi component on my table. When I click that, now it can show me what is actually happening, okay? On that table, in our say hi component, we have a logic just flowing through and printing a ton of messages every single frame, okay? You can see that again right here. It's a cool way to know if logic is getting to a certain location in your blueprint. Many bugs I've seen come from students who forget to hook up the white execution line. So they've got some nodes they think will do something, but execution never reaches those nodes. So this is a way of seeing how far does my execution get? Where am I not going? Which branches am I currently taking? That kind of stuff, okay? So pretty cool. Okay, you can see it just flowing like that. You do need to remember to actually tell it which object and actor do you care about, which component on that actor do you care about. In this case, it's the table, and in particular, the say hi component on the table. Okay, so there you go. We also have classic things like breakpoints, all right, ways to monitor variable values over time. So in this case, I right-click. I've got this cube, okay? I've got this cube. I click on the cube. I see that it has two components. I care about this show debugging stuff component. So I click on it. I right-click it. I go to edit, show debugging stuff. And now I'm looking into the guts of the blueprint, the component, the class, okay? I can see that there's a special number here and a bunch of logic that does stuff to alter it. So what can I do? Well, we'll go ahead and look through here. We got a delay. These delay nodes are evil, okay? You probably don't want to use them too often on P1. Okay, we've got this big, nice, long script, and let's say that we want to pause execution when we get to this little setting node. Okay, I can set a breakpoint there by right-clicking on the node. We see that red breakpoint. And then let's say that this special variable, I want to watch it closely. Okay, we're going to watch that special variable very closely. And now when I run the game, it will pause the game as soon as we hit this node. And I can actually look at the value of the variable right there. So it's value 0, okay? I can then step through, okay, it's now become 1, all right? I can keep stepping through, okay, keep going, yep. Okay, now the variable is 2, right? You can even go to debug and then go to the debugger, and you should be able to see those variables in real time if you want via that UI right there, okay? All right, so what is the takeaway from all of this? When you get in trouble, when you've got logic, you're just banging your head against it, won't work, why is it not working, what's going on here? You want to remember that these tools exist, and you might want to come back here, okay? That's when they'll really help you out. Another big way to debug, kind of, is turning it off and on again, all right? Now, as funny as that may sound, Unreal Engine is not always the most stable program. Game engines in general, 3D software in general, is not ultra stable. There's just a lot going on in them. Now, question, I asked this a while ago to a couple of you. Why does turning something off and on again often fix it? Why is it the classic, tech support way to resolve the problem? There's a reason that makes a lot of sense why turning it off and on again will often fix your program's state. I've got a question for you. What is the one feature that is guaranteed to be tested every single time any of your software developers run your program? What's the one moment that by definition is going to be tested constantly? The most tested part of your program is what? I'll give you another example that might make this a bit more clear. If you want to submit a video game that you've been making to Nintendo for the Nintendo Switch eShop, or to Sony for the PlayStation Store, or to Xbox for their store, you have to do something called a lot check. What is that? Well, it's a test. You send your game to Sony or Nintendo, and what they'll do is they'll put a bunch of automated testing on it. For instance, they might have a robot play the game for 24 hours straight to see if it crashes, to see if you've got any hidden errors or memory leaks that will cause the game to slow down and chug and eventually crash at the 24-hour mark. Do you think most software developers test their program for 24 hours straight just to see if it's going to keep working? No. But you know what they're always going to do? Every time they run their program, they're going to test the first 5 minutes. They have to. Okay? Otherwise, they literally can't test anything else. The first 5 seconds of a software, run cycle is the most constantly tested thing in the entire development process. Okay? The moment you have a bug that occurs in that first 5 minutes or 5 seconds, it's going to get fixed. That has to be the next thing that gets fixed, right? Otherwise, your software can't run. You can't move on. You can't do anything else. So one of the reasons that you turn things off is to refresh state and also go back to the highest quality part of your entire piece of software, okay? And that often gets it back into a good rhythm, all right? You run and use a program for 6 hours straight. That's usually when the funky business starts to kind of collect and stack on top of each other, and eventually your program falls apart, okay? Anyway, that's some fun trivia on why. Context-sensitive search is a really big deal, okay? This is why people who do not program a lot love Unreal Blueprints. You right-click somewhere in the blueprint area, and you can do a search, okay? You can find whatever node you're looking for, One interesting thing, though, is that it will actually tailor the results that you get shown based on what it thinks you want. So when you right-click, right, set physics linear velocity, you'll see that it's not here. Why is my physics, velocity setting function not here? Anyone know? Any idea? Sometimes this search will just not show you a function that you know exists. Why? Yeah. Do you know?
I thought it's like, because in this case, there's nothing before it, so it's just like you have to start somewhere.
Possibly. So in this case, we are, I believe, on an actor component and not on an actor. So actors can have their physics velocity set, but an actor component, which we are currently writing in, right, is curtain, doesn't have a concept of velocity. So you won't find it. Okay, they're going to hide it from you to try and protect you, but often it's very frustrating. If I uncheck this context-sensitive box right here, look at that. Bingo. There it is. It just shows right up. Okay, just like that. Okay. The problem is we probably can't use it. So we'll have to get a reference to another actor if we want to use that properly. Anyway, one really good technique is you can drag a node and release it. And the result, the data type of that node will actually change what you get shown. Okay, I think this shows it to you, maybe, in this GIF. Otherwise, I should have it. Quit game, okay? Yeah, so quit game right here. And then, oh, I guess not. There you go. It didn't show anything. If you uncheck the context-sensitive checkbox, you can freely search through all options regardless of context, right here. You can uncheck that, and you'll find your stuff. One big thing is that sometimes different nodes have the exact same name. This causes a ton of bugs and a lot of pain every semester. You really want to check the name of the node, but also, after you get it, check the input and output types. Because you know how there's a concept called function overloading in C++, right? Where you can have two functions of the same name if they have different parameters. So this is the same exact situation. Make sure you're getting the right node, okay? All right, another quick thing, Unreal Engine source code. So if you're really interested in this, right, Unreal Engine is actually an open source piece of software. Now, it is not a public domain piece of software, okay? You can look through the source code if you want. You cannot take it or steal it or whatever you want. But you can jump through some hoops. You can go through Unreal Engine's docs here, and you can get access to the GitHub source for the latest version of Unreal. You can build it yourself if you want to. It'll probably take a couple hours, I imagine. You can set up a different build of the source. You can make changes if you want. I'm not sure why you'd want to right now, but you could in the future. Some quick tips for using Unreal C++ if you choose to use it. Unreal C++ is macro hell, okay? Do you know what these things are right here? U-class, generated body. Any idea? These are called macros, and they're actually something that the C++ preprocessor is going to deal with for you. What's going to happen is the preprocessor will roll through this file, will see these macros, and will generate some boilerplate code to basically hook everything up. Unreal Engine is not, C++ does not have reflection. So if Unreal wants to be able to introspect and understand what classes are available to it, it has to do a bunch of funky business like this to make that work with C++. They kind of bolted a reflection system onto C++, and it works, but it's a kind of a pain, okay? Visual Studio, if you use it in Visual Studio, will probably complain and tell you things are wrong, even though they will build and it's actually correct, okay? If you want to build and patch, you can't build using the normal Visual Studio buttons at the top of the screen. You have to remember the hotkey Control-Alt-F11. If you do this, everything will be fine. Unreal will make a build and then patch it for you. If you forget about this, though, endless pain, and you won't be able to get anything to work. All right. Unreal does not like standard C++ data structures like std string or std vector. They have their own versions of all of these that were made to be more performant, but they were also made before the standard template library was stable and popular. Unreal Engine is about as old as the standard template library. Okay? Amazing. Absolutely amazing. This is really old software that has survived through the ages and been very successful. Okay? Another thing that's amazing and very terrifying, if you ever put a U or an A as a prefix to any of your file names or classes, Unreal will auto-include them in their build process and will get really, really nasty if those classes don't have a specific format. Okay? So the takeaway here is that if you go into Unreal C++, things are going to get real spicy real fast. Okay? And so just be ready for that. There are a lot of foot guns. There are a lot of ways to mess this up. But really, one really cool challenge here is that in a commercial, industrial-grade AAA project with millions of dollars on the line and hundreds of people on the dev team, you will usually write blueprint components as a prototype. And then once they're working, you'll convert them into C++ later to make them more efficient, make them more robust. And often, you will write C++ core systems for your project, and then you'll actually create new types of blueprint nodes so that your game designers can interact with those C++ systems. Okay? So it's a hybrid approach that you find in most commercial projects. But in this class, we'll be focusing mainly on just normal blueprints, okay? It's just out of scope for this course. We'd need an entire 4 months, I think, to get you feeling comfy with these, and we don't have that, okay? So blah, 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 blah. Okay, da-da-da-da-da. All right, okay, I think that's good. One last thing that I want to tell you, and I'll just tell you this vocally. When you are storing global state, be very careful about where you put it, okay? If you create a component, for instance, a fire alarm, right? Fire alarm, okay? You interact with the fire alarm, boom, turn the fire alarm on, and all of the lights in the room should flash, okay? Well, you shouldn't put a Boolean onto the fire alarm component, okay? Because you might have multiple fire alarm components, fire alarm components, and you're going to have another copy of that Boolean, is fire alarm on, in all of those components. So you want one single authoritative Boolean. Is the fire alarm system blaring, right? Don't put that on the component because you'll have many components, thus you'll have many copies of that Boolean. Put it onto your game state, okay? You remember how you did that when you were dealing with the curtain in the magic show, right? You had some variables, you put them on the game state because you wanted to be global. Variables like, is the curtain currently up? Are people clapping, right? Are the audience members jumping around and cheering for you? So remember that. That's a big bug that's very, very common. People think something is global when it is not. It is one of many copies, okay? All right, that's all I've got for you there. I want to take 5 minutes, and we're going to come back. We're going to talk about environments in Unreal. Kind of a simple talk, but we'll be introducing you to the topic of materials, what they mean, what they are, why they matter, in just a bit, okay? So, see you then. What? So,
Other projects do. Like,
yeah, you can set up over there. Okay. Okay. I think we're back to it. Okay. So, with the small amount of time we have left, I want to do a really quick lecture. Okay. I want to talk a little bit about what materials and what materials are. And the kind of interesting ways you can deal with and mess with materials as well. Okay. Materials are a huge deal when you go about trying to recreate a space authentically, like you're trying to recreate the lab. And materials can be a huge deal in real life too, okay? First, you should know for context that, let's say I'm remodeling my house, which I was not too long ago. I'm trying to knock down some walls, something you want to be very careful about doing, okay? Let's say that we really want to take this wall and just knock it out. We want to join the kitchen area where the camera is with the living room area, which is just through that door. What do? Okay, what do you do? Well, you might say, if you are in a game engine, that this is quite easy to do, right? You simply select the area you want to get rid of, the object that comprises it, and delete it, okay? Super easy. You've now knocked down the wall. 3 seconds, no big deal. That's the magic of game engines, okay? If you want to do this in real life, you have a horrible situation, okay? A horrible problem, all right? And my dog is looking at me over there thinking, what are you doing? If you want to knock down a wall or change geometry, if you want to do modeling in real life, what do you have to kind of worry about as you go and cut into the wall? Any ideas? Yeah.
What it's made of.
Yeah.
What the stuff around it is made of.
Yeah, what is the wall made of? Can you cut into it? Is the wall a load-bearing wall? Okay, you shouldn't get rid of it. Your house might collapse if you do so. What is inside the wall? Because people put things inside of walls, right? Electrical equipment, for instance. You don't want to cut into that. It could start a fire, right? And so it is possible to do, but a huge pain, okay? Very much worth it, but it takes 3 hours in real life, okay? The magic of game engines. When it comes to materials, okay, when we went and made our changes to the wall, right, when we went and made our change to the wall, we messed a bunch of stuff up. The paint got kind of splattered, okay? It's uneven, right? We had all this nastiness from trying to remove the wall. We damaged parts of other walls, okay? How do you fix this kind of thing? The answer usually is to paint over it. So we're going to do that because thankfully we're in a game engine. Ambient CG is a wonderful, wonderful website. If you go there, you will find an endless amount of free public domain materials you can just download, okay? You will find assets like this, okay? And when you download a material, you'll find not just one image, but you'll find actually a bunch of them, which is a bit strange, isn't it? Okay? How is this made of all of these, okay? Have you ever seen this before? You download a material and you're like, I'm going to get an image, right? I can just drag it in. And then you get like 5 of them. What's that about? Well, I'll show you in a sec. But the bottom line here is that you can drag these materials into your game engine, like I just showed you right there on the screen. And then you can actually find what's called the color, the albedo texture, and you can just kind of drag it right in. Okay, and you will get a change to your material. Okay, boom, just like that. And it actually looks all right. Okay, it looks kind of like plaster. That's all we really need. Okay, and it loads and finishes, and boom, right? Not too bad. 1 minute, okay? 1 minute. If you want to do this in real life, it's gonna involve you going to the Home Depot or Lowe's or someplace, buying paint, hoping you got the right color, okay, hoping you don't mess it up, and then painting for about a day because you're going to have to do multiple coats, one after the next, and it's a gigantic pain in the butt, all right? You're going to need special equipment to do it fast. It's very, very annoying. Building environments in general is exceptionally tough. There's a lot to learn. Okay, if you look at gigantic worlds like those of Elden Ring, you can really appreciate just how long it took. However, these are digital worlds. Okay, I want you to imagine how much of a pain in the butt it is to be a 3D modeler in the real world. Okay, where you can't just easily manipulate digital assets and drag them around and delete walls and grab materials from the internet and just pop them on. No, you got to paint everything. You have to sculpt everything, okay? Good luck with that. So when it comes to building environments, it really does, we really do are incentivized to go and kind of learn a bit more about that, to explore what are these things made of? How can we do it? This is a little bit 298 material, but it'll be worthwhile. Gray boxing is the standard technique that you start with when you're creating an environment. You already know this. We talked about it briefly, okay? But it is something that people do even on AAA projects, okay? And you can actually see this. This is a very well-known game, Uncharted, for the PlayStation 3. Very luxurious environments, but they didn't start that way. They looked like this initially.
Good thing. You were never very good at poker. I will find her. Trust me. I mean, how much trouble could one girl be?
Right, so you get a feel for it, right? So gray boxing, you do this for environments. You also do this for things like cutscenes, okay? So when gray boxing gets old, we eventually turn to materials. And materials are one of the things that you'll have to put some time into for this first project, okay? So a question, all right? These boxes are different, but they're different in more than just color, okay? When you think of color, you think, hey, I want this box to be a bit more red, I want this box to be a bit more gray, but there's actually more to it than that. How do these boxes differ besides color? Yes?
One's like more metal and the roughness.
Yeah, like there's a certain element of age here, right? They're both clearly kind of metallic, but this object has dents in it. It has warts and divots, and this is a much smoother bit of metal, right? So here's another challenge, okay? These boxes have the exact same color, okay? They have the exact same tint, but light is reflecting across their surface in a different way, aren't they? Okay? This is where we get to materials and the idea that color or albedo is not the only thing that we care about, all right? Question, let's see here. I'll give you an example, a real life example. Do you see this whiteboard right here? Okay, this whiteboard and this wall and the table in front of you, they are all colored about the same, right? They have the same albedo. Their color is the same. They're all white, okay? But the question is, there's something different to them, right? The way that this whiteboard reflects the light, it's very glossy. There's a glare. You can very clearly see the light on the whiteboard. Over here, you can't see it nearly as much. The light is much more scattered. If you feel it, it's not as smooth, okay? And certainly not glossy in any way. What about this table? It's very smooth to the touch, but it doesn't reflect the light very smoothly. It kind of scatters it, right? So you don't get that glare in your face while you work. So these objects have the same color, the same albedo, but they have very different reflection and smoothness properties, okay? So these scratches and dents, do you see this little wart at my cursor right here? Right? There's a little ball here, okay? Little dent. A question for you. Do you think that a 3D artist went in and created all those little warts? They like punched the holes in, okay? Is the geometry of this object super complex? The answer is going to be no. This is the geometry of these two cubes. They're the exact same, despite one, the one on the left, looking much more complicated and advanced and detailed than the other one, okay? They are just a handful of quads and triangles. That's it. Very, very simple. They look so complicated and complex, but this keeps them super simple and geometrically or computationally efficient, okay? So the geometry is ultra simple. There are actually no dents or scratches. It is all fake, okay? It has all been faked. So here, we kind of learn what's going on. A material, which is these kind of ball things that you see in Unreal Engine, if you click on it, it'll open up. And we discover that a material, the way that something looks, is about more than just its color. It can't be properly represented by just a single image. It needs several, okay? And if you open up a material, you'll get a feel for what this is, right? We have our base color, which is this kind of white color, but there are all these different slots in here, okay? And we can see that one of our little images, the painted plaster color image, has been plugged in right here into base color, okay? But if I get rid of it, we go back to kind of default, and I can instead put in a color like this, okay? And I can make it black, or I can make it a different color, right? Full red, right? So we can feed a texture into these nodes to change how they look, or we can feed a raw color in via this node down here, okay? Well, you could say, well, we've got other nodes, so what do they do? We've got base color, which we've already seen. It kind of tints things. But we've also got a metallic node, a specular node, okay? Shininess, right? Roughness, smoothness node. An emission node, in case we want our material to emit energy and light, as if it's growing with energy, or glowing, right? We got a bunch of other stuff as well. There are just so many inputs. Let's check out this video real quick. Here, what we're going to do is we're going to mess with the metallic node, okay? How are we going to do that? Well, let's just grab a constant number, and we're going to plug a constant into metallic. It's not metallic at all. It's 0, but when I make this 1, look, it's shinier. It is noticeably shinier. It's more metallic. If we punch it, oh, I guess we won't punch it all the way up. Will we? Maybe? Make it super shiny? No, I guess not. Let's adjust the roughness. So I can go in and I can plug a number into the roughness channel, and now it's not rough at all, right? We've plugged 0 in, and it becomes smooth as a mirror. The roughness level is 0, super smooth, okay? Now, if I make this go up, like 0.1, now it's kind of like a blurry mirror, and it's getting blurrier, more frosted, okay? Right? Looks very nice, but now it's not nearly as smooth. It's getting rougher and rougher. Eventually, we can see no reflection. It's just scattering the light like crazy, okay? So anyway, we're playing around with these different properties on the material. We can plug numbers into them. We can mess with them however we want to do it. So we're going to plug another constant in. Okay, this is going to be a constant 3. So RGB, it's a color. That makes sense. Okay, we want, let's say, 1 red. RGB 1. So look at this. You can see that red energy kind of boiling off of it, right? Now, what I always love to do is I love to just punch these numbers as high as possible. Looks like we're making yellow, so we're kind of making the sun here. Okay, and this is going to give us like a glowing white, so I'm kind of a magical orb effect. I'm going to take this red and I'm going to punch these numbers to 999, and let's see what happens. Okay, it's going to finish, and oh my goodness, it is exploding. It is a star going supernova. It is emitting so much light energy that it takes over your entire screen. Okay, so we're just going through and we're playing with these kind of really powerful little bits of little elements of what makes a material a material. Okay, you can make things like glass, see-through glass. You can make things like metal pieces of an object. Okay, you can draw objects and icons onto a material. We'll show you that all in a sec. You saw that I was plugging in numbers, but you can also plug in textures. Okay, why is that possible? Well, what is a texture? Do any of you know? It's an image, right? That's how you think of it. But in reality, all it is a 2D grid of numbers. All right? That's it. It's just a 2D grid of numbers, usually 3 tuples, RGB. So watch this. We have our glowing, burning red sun right here. Okay? What we're going to do is we're going to take this texture sample node, and this is going to allow us to feed a texture into one of these channels. All right? I'm going to go into GIMP, which is basically Photoshop, and I'm going to draw a little face here, okay? A little face. So understand what these are, okay? Where you see black, these pixels have a value of 000 for RGB. Where you see pure red, you've got values of 255, okay? And so these pieces of data are going to be fed in pixel by pixel onto our material. And so I'm going to drag in that texture that I just made. Okay, here it goes. Okay, dragged in the texture, and now I can find it, search for smile. There it is, right there. Okay, the texture is now in there being sampled. You can see it. Now we're going to feed this in to, it looks like the emissive color, okay? And you can now see the colors coming through on the object, okay? The material has been edited. We've been able to draw things and all that good stuff. And if you want to get even crazier here, look at this shiny little mirror, okay? The entire ball is just super shiny right now. Now it's not super rough. Now it's shiny again, okay? We're going to feed another texture into this material. Let's say this. What would you do if you wanted the top half of this ball to be shiny, but you wanted the bottom half to not be shiny at all, not smooth at all? How do you apply a lot of smoothness to only one part of this object, this material? Well, here's how you do it. You can go into a drawing program, And you can treat this drawing program as basically you creating a 2D array of data, okay? So for the roughness channel, we're going to have a value of 0 at the top, okay? So super smooth at the top, but on bottom, we're going to have 255, right? 255, 0, 0, and that is going to affect things. Oh, now it's actually 255, 255, 255, so pure white, okay? Okay, we export that image. We're going to bring it in to our project, just like we did last time. Okay, drag it in. This is called toponly.png. All right. And we're going to select that image, top only. Okay, we're editing the material. We're going to drag it into roughness, and now look at that. Only the top, only the area where I drew the black color is going to have no roughness. Where I drew the white color, which is 255, 255, 255, we have full roughness, okay? And this now allows you to draw and decide where you want certain effects to be. Isn't that amazing? You don't think of textures and images as tools, okay? Containers to ferry data with. But here we discover that it's really the case. I want to show you a really quick example of something, okay? And I'm going to pull this out really quickly, okay? Let's go to itch.io. And go to itch.io. I'll log in. Oh, I'm already logged in. That's nice. Okay, dashboard. Okay. Okay, so this is a project called Goodbye Groundhog. It's a game that I made a while ago, a number of years ago. One thing that was cool about it, it was an okay game, but if you look at it really close up, you can see that this is a game based around snow. You're on a snowy mountaintop, and as you walk through the snow, you actually melt the snow. It's a super cool effect. As you walk around and explore, you feel like you're walking through a very cold kind of snowy mountainside. But as you get into fights, you can also see where our enemy is running, where our bullets shooting, because they actually carve a path through the snow as well. And then over time, the snow builds up again so you can watch it again, all right? So the question is, how is the snow implemented? Well, I'll tell you, the snow is just an image, okay? There's a snow texture that at runtime we draw to, okay? Wherever a character is, we draw a circle on that part of the snow. And if you have a pixel there, okay, if you have some pixel value, then that means it's melted in that area, okay? Over time, we take all the pixels and we make them get less and less colorful, and that kind of brings the snow back. There's a 3D mesh, a big cube 3D mesh with lots of vertices that samples that texture and says, hey, if the pixels I'm near have color, that means I should melt. So that vertex is going to be going down, okay? That makes it melt. And so the takeaway here, you don't have to understand those details, but the takeaway is that very often for special effects in games and films, you're actually going to be drawing onto a texture, and that texture then gets used to control vertices or objects or something to get some cool effect. It's usually called a map. So this would be called a snow map. All right. Anyway, that's just a tangent. Textures are super important. They get fed into materials and shaders all the time to do super funky, cool stuff. Okay. All right. You save the asset, and then suddenly your material changes to look something like this. Okay. It's super smooth in parts, and in other parts, the bottom half, it is super rough. Okay. All of these images that come kind of packaged in when you download a material, they all have their own purpose. They all go to making a material look a lot better. Make the reflections work, make the color work out, make the metallic parts look good. If you look at this vehicle, okay, the materials, certain parts of the car's material are very shiny, other parts are not so shiny. Other parts are not shiny at all. And they're tinted in various ways depending on the part of the car it is, okay? So textures are extremely expressive, and they can be wrapped around geometry, Here's a really fun GIF. I like this one a lot. This is how you tend to put materials and textures on a 3D object. You take EECS 298 next semester. We'll go way deeper into this. But do you agree with me that this is a 2D shape? You could go into Photoshop and you could draw onto this, right? Well, watch this. We're going to wrap it around the object and make a 3D shape, just like that. Okay? And this is how UV wrapping works. Okay? You've got a complex 2D shape. The artist draws onto it in a certain way, and when you fold it in the right pattern, you get 3D shapes. Okay? Absolutely amazing. So this is how you typically get certain textures onto a character or an object. Here's a good example. This is Mario. These are the textures from Mario from Super Mario 64. Okay? This is the underlying geometry of Super Mario 64. And as it turns out, you can actually take these textures, and if you wrap them onto the model in just the right way, you get a nice model. Okay? It looks like the eyes are a little bit messed up, but it's fine. Okay? UV mapping. All right? Texture mapping, it's sometimes called. Here's a human. All right? Now, this is creepy, but you have to admit, if you took the skin around a human skull and kind of unwrapped it, chances are it would actually look something like this. Okay? This is what a human artist needs to draw or somehow generate or come up with before it can then be mapped onto a character and made to look good, okay? These textures have a lot of data in them. They are big 2D grids, and each pixel has 3 to 4 floats, RGBA, okay? That's a lot of data. You can store a lot of information like that. Yeah, sometimes a pixel's color doesn't mean its color, okay? So a good example, right? In here, a pixel's color means how much roughness do I want, okay? Up here, the color value, the pixel value is 000, so I want no roughness. Down here, 255, 255, 255, I want full roughness, okay? In a project like Unity, you have a material inspector that allows you to go in and customize the material, plug things in, blah, 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 blah. In Unreal, you have what you already saw, okay? Here's a fun example, okay? These 2 coins are from 2 Mario games, all right? In Super Mario Galaxy, we have this coin, which you see up here, okay? And if you look, it has a ton of geometry in it, a lot of triangles, a lot of vertices. It's very complicated, okay? And computationally, it's difficult to deal with. The GPU can only handle so many of these vertices. We're almost done. However, over here, we have the Super Mario Odyssey coin, which has a much more simple geometry, and it looks better, right? If you asked, is this coin more complicated or is this one more complicated, I think most of you would say this one, right? Well, it turns out that it's using good shaders and a better material to fake this look of depth. Even though there's no rivet here in the middle, it fakes it, and it ends up looking really good. Okay? So I think that's actually it. Kind of a quick lecture on materials. But again, the takeaway is that if you ever want to mess with materials to make a certain object or wall or anything or environment look really interesting or weird or good, you got to get yourself in there to those materials and start playing around with these nodes, okay? Just like with blueprints, there are interesting new nodes to learn. And if you plug them in the right way, you can get some really interesting effects, okay? All right, everyone, thanks for dealing with my rushed lecture here. I appreciate it. And we're going to see you on Wednesday for that film, okay? Remember, no lecture on Wednesday. It's just the film. Yeah, good luck on P1 Alpha. Please start it as early as you can. These tasks are pretty involved, but you will be able to take care of it, okay? We will see you next time. Take care, everyone. Office hours tonight, 6 to 8 p.m. We'll see you. Okay, take care, everyone. Bye-bye.